All right. All right. I'm stuck here. Okay. Good start to the movie. Okay. Blah, blah, blah. Maximums, minimums. If you don't know those, you're gone. Anyway, so I got to do this again. First hour didn't tell me I wasn't taping. Their fault. All right. And then the minimum is the Y value located at the X value. And I used values that are on this graph and complained that the Y value and X values were equal on the first two, really focus on this one. And this is an absolute maximum because there's no um, higher value there. All right, then we were going to even and odd. And I guess I should do the noise again. So you got to go through that again. Okay, so even functions are symmetric with respect to the y-axis. Okay, so there you go. But if I don't have a picture, then here's the test. Okay, so this should be review. I don't know about this though. I don't know if you did even and odd tests last year. Apparently someone has a question. All right, what? That's f of x. Come on, man. You don't like the f I have there? All right, it's an f. It's fancy. Okay, and what are the two straight lines? What are the two straight lines? What is that called? Apps? No, apps. That's the value. All right. Now, what's a negative squared, everyone? Are you okay? She's shaking her head. What's a negative squared? Positive. And then, you know what I could do on this? I could break this down into -1 times x like that. I can think of it that way. What's the absolute value of -1? 1. So here's what we got. Mathematically, algebraically, I mean to say, we have the exact same thing we started with. That's what this means. I plug in a negative for x, I do my algebra, and I end up with exactly the same thing I started with. If that happens, that ensures this symmetry. For any x, the opposite of x will create the same y value, therefore have that y-axis symmetry. Very simple. Okay, and then now we got this one. You ready? Here's the symmetry for this. Oh, I went a little crazy there. There we go. So what kind of symmetry is that? Origin. That's the origin. That's the XY intersection axis. So you will have symmetry about the origin if you have an odd function. Yes, the word odd comes from odd exponents, but there's more than just polynomials that could be odd. Plenty more. The Federmac, the graph that you just saw previous on the AP exam, which was a cosine graph. I did say that, right? An upside down cosine graph. That one's even if I went before the x-axis. The sine graph is odd. So we'll talk about that when we get there. I just want to make the point that odd is just not polynomials with odd exponents. There's more to it than that. But here we okay, there we go. That's an F. Oh, all right. Just thinking about making sure we knew that was an F before I continued. And then we do this. No, wrong. I did that wrong. Wrong, wrong, wrong. Come on, back button. Don't have time for this. And then 1 over negative x. We could do that. Okay, what's a negative cubed? Negative. So really what ends up happening is this, and I'm going to fast track this. These are both negative. I can pull that negative out in front just to, have a different look at it. And then just understand that this is the original, but it's exactly the opposite of the original. Got it? Or every single term, you could just look at the previous step. Every single term is opposite of what it was before. All right, so you don't have to do that last step. So that is this proof. That is this proof algebraically. So whenever you have an equation and you're asked if it's even or odd, I need this work. Got it? That's why I'm going over this. This is probably I wouldn't call it hard, but it's probably the only thing that you might really need today. Then the rest is review. We know about x and y intercepts. I'm done with that. If you don't know that an x-intercept is 0 for y, there's the door. Get out. You're gone. Hasta la vista, baby. Anyone know what that movie is? One of the greatest lines ever. Nobody knows? Terminator 2. Who said that? Nice. Okay. Hey, by the way, what's square root of a negative? Imaginary. What does that mean about the x-intercepts? What does that mean? Do they exist? I don't have time for this. Okay. All right. So no, there's no x-intercepts. That's because this is a parabola that's up one and goes up. So if you think about the picture real quick, yeah, of course there is no or are no x-intercepts. And then the y-intercept, you plug in 0 for x. Shh, whoever it is yip yapping over there. Got a big yip yapper in my seventh hour already. All right, and then that's 0, comma 1. And I just actually grew, you just saw that because that's where the vertex of this parabola is. I don't think I want to do all of these. Oh gosh, I'm only doing one of these two. Oh, yeah, let's do this one. No, I know why we have to do this one. Gosh, dog it. I'm only gonna set it up. Actually, Mrs. Gray came by and said we're not gonna worry about a certain thing. Nobody watched that video because I actually sung a song in the video as well. Bummer. I don't know if this is factorable. You know how I could tell if this is factorable though? Are there two numbers that multiply to -8 but add to 7? Yes or no? This is a test if it's factorable. You guys ever do the four-step method of factoring? Doink, 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 doink. I'm not doing it. But does something multiply to -8 and add to 7? Yes or no? Two numbers? Yes, thank you. Everyone's looking at me like a lump on a log. All right? So now I got to figure out the combination. Okay, so how do I get 7 in the middle? I know what 4 is. It's 1 times 4. So I like 4 because why would I put it here? What's 2 times 4? Good FOILers, good factors. What's 2 times 4? 8. And then I throw a 1 in there and I could bring it down to 7 because this has to be, one of these have to be negative. This is positive, so this is plus. Right? And there's factoring 101. Did we do that yesterday? Did we walk around the board factor? Did we do good FOILers, good factor? Did I make you guys say that sometimes? Okay, good. All right, what time is it now? Time check. 8:11. Okay, so when I don't know why I changed colors. I have no idea why I did that. Okay, when I set this equal to 0 and solve, I get 1 over 2. When I set this equal to solve, I get -4, comma 0. Okay? Or 4, yeah, -4, comma 0. And then the y-intercept, forget about it. When you're in this form, the y-intercept is 0, comma -4. What was that scratch out there? I plugged in 0 for x. The y-intercept is that last term. It's very simple. Okay? And then this last one, this is not factorable. I'm only going to set this up, but I don't think we're going to make you responsible for this in your homework according to Mrs. Gray. You ready? If this is not factorable, what do we have to use for the x-intercept? By the way, I plugged this 0 in there. What do I have to use? Are you ready? The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. He's got a yip yap again. I wasn't done with the song and he interrupted. All right, now I don't get a negative square root in there. You'll continue to simplify that, and then just be aware that this is coming, the quadratic formula. I'm not going to complete this, okay? It's not the main idea today, but you better remember that quadratic formula and get going on it. All right, here we go. Can everyone say average rate of change? Then he doesn't say it. He's been yip yapping the whole time. Then I ask him to say something. Nothing. Nothing. All right. So average rate of change is slope. Write this down right now. Average rate of change, slope. Okay, that's exactly what it is. Very, very simple. I'm going to tell you right now, AP is obsessed with this concept. You'll be doing average rate of change all the way through till May. Every single thing that we graph. When we go into that cosine graph in February, you will have to find average rate of change of points. And actually, it's a calculus concept turning into tangent lines and slope of tangent lines, instantaneous rate of change instead of average rate of change. So it's a big calculus concept. And then don't overdo this. This is just a form of y2 minus y1 over x2 minus x1. It's just in function notation, right? Okay, so we should recognize that formula there. Okay, so that's what average rate of change is, and then we're gonna break this down. As far as some components that you should know about a function. Hey, what is you know what? You probably did this almost a year ago. This is literally 12 months ago that you graphed this in Math 2 Honors. What's the vertex of this V? You better remember that this is a V. What's the vertex? 3, 2, 1, go. 4, comma, 7. That is true. 1, 2, 3, 4, comma, 1, 2, 3, 4, 5, 6, 7. Now, I will tell you this. You can graph an absolute value if you know it by using that -3. Because really what this is kind of linear, but that absolute value part, 1, 2, 3, 1, flips one part of the line and turns it into a V. If you remember this, 1, 2, 3. And if you don't like what I'm doing right now, input, say it. You go ahead and set a chart of values, plug them in. I'm just going to take one of these because of time. 1, 2, 3. So 3, comma. So apparently 3 should give me 4. 3 minus 4 is -1. Uh-oh, that's not right. Hold on, let me see if I did this right. 1, 2, 3. I'm freaking out, man. 3 minus 4. Oh, yeah, okay. I'm a maroon. 3 minus 4 is -1. What's the absolute value of -1? 1. What's 1 times -3? -3 plus 7 is 4. And you can do that for all these coordinates. 5 does the same thing. 5 minus 4 is 1. Absolute value of 1 is 1. 1 times -3 is -3. Same thing. Oh, by the way, is this function even? You must say something. Yes or no? Not. You have to wait. Is this function even? Yes or no? 3, 2, 1, go. Yes. Wrong. Okay, because here is the y-axis. What? Is there anything over here for this point? Yes or no? No, it's a trick. It does have symmetry, but it has symmetry with the x equals 4 line, not the y-axis. So I tricked you. It's not even. All right, so domain and range. Oh, here we go. Let's get this bad boy or girl, depending on how you feel about graphs, finished off. So what's the domain? All real numbers. I can plug in any single number I want and make this happen. I don't know if I have time to do all these domain and range issues. Time check. Okay, but the range is all of these numbers from down here all the way up to here. So I'm going to highlight that. So the range is limited from -infinity all the way up to that y value of the vertex. So be careful and know how to read a graph and read the range. All right, very important. Oh, intercepts. What? Yes. Yes. Yes, I wasn't done yet. Yes, you'd bracket the 7. What are you laughing at? All right, now I'm not going to do x or y intercepts, but what I do for the x intercepts is I plug in 0 for y and then solve this. And I think it is pretty doable there, but I think we end up with a fraction, a couple of them. So we're going to have both, and then for the y-intercept, that's not as bad. Plug in 0 for x, all right, and then evaluate. But there's a lot going on in these notes, so I don't want to labor us with too many things here. So just do that, plug in, and do your solving. For the limit statements, hopefully you know that, right? We covered that yesterday, and I don't want to go into that too much further because I could see the time, and I told you this is going to be chock full of information today. All right, we have a lot to do. Intervals of increase and decrease, remember for that from yesterday. This is the interval that creates this. That's an increasing interval. Maybe I will go in blue. So increase is from negative infinity up to the x-coordinate of the vertex, which is 4. All right, and then those do not have, never for increasing and decreasing do you use a bracket. Think about it at 4, there's a change in direction. So 4 is like where it flips, so you can't really include 4 in an increasing or decreasing scenario. All right, and then this is where it decreases, which is these inputs. Right, they don't have salmon, so I'll just do this. Decreasing is what that D is, and then that's the opposite. It's 4 to infinity. Squeeze that in. Extrema, yes, we have an abs max of 7 at x equals 4. Just make sure you got that taken care of. And now, average rate of change. This is what you need to understand. And actually, it's pretty easy with this, but we'll do this on another one. It is slope. We should already know the answer, because from -2 to 0, that's this interval right here. And this graph, oh, sorry, I skipped. That's -2, that's 0. And this graph forever goes down here. So basically, from -2 to 0, it's the slope of this part right here. What is that slope? What is that slope right there? It's actually in the equation itself. It's not -3, right? It's what? 3. It's because it's going up. And on the other side, it's -3. But that's literally what you do. You take these coordinates and you find the slope between those two with a formula. We could do that on the next section, but we'll just say that we understand that that's at 3. And then from 1 to 3, well, I think from 1 to 3, we got the same thing. We got this little thing here, which is still 3. Now, concavity, there has to be a curve for concavity. Is this curved, yes or no? No. So we would say none. And then I already got you on the last one. Neither. Okay, I tricked you. Okay, I don't think I want to go through this. Whenever you have an absolute value, the average rate of change is sitting there right there. It's either positive or negative, depending on what part of the V you're on. This one would be facing up. I know we're running short on time, so I have to cut our losses here. Got it? Okay, because really what we need to do is start graphing these and then talk about some characteristics in a table. Okay, you should know input output 0 squared is 0, 1 squared is 1, 2 squared is 1, 2, 3, 4. 3 squared is 9. I think this goes up to 8. I'm going to guess. And I want you to understand that there's a difference than an absolute value. This is more curved. This is a curve. So we do have that. Whoa. So much in these notes, and Mrs. Gray even shortened them. I remember last year I cut a whole bunch out of here. It's just too much, way too much. But actually, let's do average rate of change now. From -2 to 0, -2 comma, 0 comma. What you have to imagine is, I don't know why that happened, is drawing a line through these 2 points that they are asking what is the average rate of change. Or, input say it, 2 comma 4, -2 comma 4, take these two coordinates, -2 comma 4 and 0, 0, and find the slope. But actually, I could have just found the slope of the line I'm looking at, rise over run. But I'll go ahead and employ my slope formula just for giggles. 4 minus 0, -2 minus 0, 4 over -2 is -2. Well, look at this. 1, 2, 3, 4 divided by 1, 2, negative. Actually, the 4 was negative. So when I look at this graph, it's -4 down and then 2 to the right, you still get -2. Got it? This is all average rate of changes, finding the slope. And then between 1 and 2, that's, oh, let's do this one. This is kind of weird because it's going to look like it's kind of going like along with this, but it's not. There's 1, there's 2, there's that line. So you're actually finding the slope of that line. Okay, well, I'm just going to do it this way. 1, 2, 3, and then over 1. That slope is 3. Okay, so we got a different situation there. Average rate of change. Do I have concavity up or down? Yes or no? Concave up. Is it even or odd? 3, 2, 1, go. Even. Come on. Okay, that's an even function for sure. Okay, are you putting your stuff? Oh, you're getting the highlighter. I thought she was packing up for the day. You know what? I've had enough. All right. All right. So, hey, do you guys know the 135 thing for parabolas? How many people know what the 135 thing is? Nice. Here's how this works. We could do input output. This is going upside down, and the first level of coordinates after the vertex is 2 times 1. 1, 2, 1. See, that 2 actually makes it skinnier, that graph. Or you could input, say it. I can plug in -1, evaluate, and get -2. I can plug in 1, square it, multiply, and get -2. 1 comma -2, -1 comma. That's the point you're looking at right there. Then the next one is 2 times 3, which is 6. 1, 2, 3, 4, 5, 6. And then over one more. And then guess what? Is this even? Yes or no? Yes. Because we don't have this shifted off of the, the middle. All right, and then you get the idea. -2 to 0, that's this slope of this line, because I want to get into some better ones. Man, they got some graphing after this. Oh, so many notes. Okay, so that slope right there is rise. That looks like 8 and over 2. Is that correct? Did I look at that right? Are these 8 spaces? Hello? Yes? It's nothing. I get nothing. All right. And then 1 to 2, that's this line right here. So it's that one right there. Right? And then that's 1, 2, 3, 4, 5. Is that 5 over 1? -5, right? Okay. Concavity down. And this is still even because I did not move it off of the y-axis. Okay, so that's why we're still even. Okay, now here is the chart of values for each of these things that I just did. -3 squared 9, 3 squared 9. Now I want you to do, this is, and I think you did this last year, first order and second order differences, but there was for other reasons. All right, so here we go. Here's the first order differences. You got to go backwards. 4 minus 9 is -5. 1 minus 4 is -3. 0 minus 1 is -1. 4 minus 1 is 3. Then 9 minus 4 is 5. Do I have too many blanks here, I think? Right? Did I? Oh, I didn't do 1 minus 0. I'm a buffoon. Okay, what's 1 minus 0? Okay, so 0 minus 1. 1 minus 0 is 1. I don't know why I changed colors. 1. And then 4 minus 1 is 3. There we go. And then 9 minus 4 is 5. All right, and then this one. Oh, here we go. -8 minus 18. Isn't that 10? Check my math here, right? -2 minus -8, which makes that +8. That's why I get 6, right? Right. And then 0 minus -2 is 2. -2 minus 0 is -2. -8 minus -2 is -6. And then this is -10. Okay, what I want you to see here is this. This part right here, the first order differences up to this point, notice the graph in these coordinates is decreasing, right? Because this parabola is, decreasing at this point. So that's what those first order differences are telling me about this graph. Second part, these are positive. This is where the graph is increasing. It's increasing because the differences in the y's, as I go right to left and subtract, they're positive. That means they're going up as we go. So we should make sense out of that. Okay, so this is increasing part of the graph. Same thing here, increasing, decreasing, right? Because the graph is upside down. But now let's take 1, 2, 3, 4, 5. Yeah, there's 6 of these. Let's do the second son of a nutcracker. I really get nut crazy when that happens. Okay, let's take the second order differences. Now, and I don't know why there's 2 columns here, and I don't have enough. I need one more, I think. Oh, no, I don't. Okay. But what's -3 minus -5? 2. What's -1 minus -3? 2. What's 1 minus -2? 2. 2. First of all, the fact that these second order differences are equal proves that this is a quadratic. If the third order differences were equal, it's a cubic. I think you did that last year, yes or no? Okay. But it's really important that you understand that all of these are positive. You know what that means? The graph is concave up. Isn't it concave up, right? So did you say I don't know? Okay, it's concave up. All right? And that's what happens when the second order differences are positive, that determines concave upness. Okay, next, 6 minus 10, negative 4. I don't know, I'm just not changing colors. 2 minus 6 is negative 4, negative 4, negative 4, negative 4, negative 4, negative 4. So, first of all, that means it's an x squared. Second order differences are equal. We already knew it was an x squared. I saw it, but it's proved in the data. But now this is concave down is what that determines. And I don't have any other, I'm not, what time is it? Ah! Okay. Okay, so we got to get going. All right, a couple things to remember. Hopefully you can do all these things now. I'm not going to get a chance to do this on this, all right? But I want to remind you how to graph. Got it? So the first one, this is simple. This is vertex form. What's the vertex? No time. Answer. 3, 2, 1, go. Negative 3, 5. Negative 3, comma 1, 2, 3, 4, 5. And then negative 1. 1, 3, right? I'm doing the 1, 3, 5 thing. Not even, but I did do symmetry over that x equals negative 3 line. And then 5. 1, 2, 3, 4, 5. 1, 3, 5 rule. Hey, at least I know the y-intercept. Right? Find the x-intercept. You plug in 0 for y and you solve. Do that in your homework. I should not have to show you that. All right? Because really what I want to do is remember how to graph these is the most important. Okay, listen. What is the formula to find a vertex when it's in standard form? I sang a song earlier, and part of that song is part of this formula. Yes? Remember, the opposite of b plus or minus the square root of b all over 2a negative b over 2a, that part of the quadratic formula, when you lop off the plus minus gives me the x-intercepts. This is the middle of the x-intercepts, which is the vertex's x-coordinate. And then what you do is plug it in to find the y-coordinate. All right, what time is it right now? We got to get our phones. I'm just here to remind you of this. This last one, this is x-intercept form. 1, 2, 3, 4, negative 4, comma 0, and 2, comma 0. Guess what? The vertex's x value is right in between, which is right around here. So the vertex would be negative 1, comma. You got to plug it into the equation to find the y-coordinate, right? Does all this seem familiar? Right? So, sorry for fast tracking that on the end, but that is 100% review. I ran out of time for doing the vertex on that one. So we've got to get our phones. And then after that, you could answer all these questions after you have a sketch. Got it? Okay, so I just wanted to remind you of those things. Some of it was new. I feel like most of it wasn't, though, but we'll see.